Hi everyone, and welcome once more to the Allplane podcast, where we talk with the movers and shakers that are redefining the future of commercial aviation. As usual, before we start, I would like to remind you that all previous episodes of this podcast, as well as many other aviation stories, are available on the Allplane website. That's Allplane.tv, Allplane.tv. And by the way, you can also subscribe to the Allplane newsletter, in which you will find on a pretty much weekly basis lots of interesting stories about innovation and sustainability in the commercial aviation industry. Today on this podcast, we continue our exploration of the eVTOL/advanced air mobility space. Our guest today is Michael Cervenka, Chief Technology Officer at British eVTOL developer Vertical Aerospace. Vertical Aerospace is a very interesting project. Why? Well, because the eVTOL that Vertical Aerospace is developing, the VX4, has received a considerable level of interest from commercial operators. Now, if you remember, a few weeks ago, we had here on the podcast Mark Temblecke, the head of Avolon E, which is the innovation arm of Avolon, a pretty large leasing company. And he told us how Avolon has ordered 500 of Vertical's eVTOLs and managed to place them, all of them, within a matter of months with a handful of airlines from all over the world, including names such as Japan Airlines, AirAsia, or GOL in Brazil. But this is not all, because in addition to these 500 orders from Avolon, Vertical has another 1,000 orders from other operators, and those include names like American Airlines or Virgin Atlantic, so pretty strong brands. So what has made so many respected aviation companies put their trust in Vertical's project? Well, we talk about this with Michael as we review as well some of the key technical and operational characteristics of the VX4 eVTOL. What's more, Michael shares as well some insights about the development project as it stands now and the next milestones ahead for Vertical Aerospace as it prepares for its first untethered pilot flight. So without further ado, let me welcome Michael to the podcast for an in-depth conversation about one of the most exciting eVTOL projects right now in the market. Hello, Michael. How are you?
Hi, great to see you.
Thank you very much for coming on the line today to talk about Vertical Aerospace, which is one of the most interesting eVTOL projects, I think, in my opinion, not least because it's got quite a few orders already, even if it's still in the development path. But it's quite impressive the amount of interest that the VX4, which is the name of the aircraft, has generated in the market. So before we get into these details, I just would like to ask you to introduce yourself and tell us a bit more about who you are and what's your role at Vertical Aerospace.
Well, thanks very much for having me. Great to do another podcast. It's always fun to talk about what we're doing in Vertical. It's a really exciting time for aviation. So my name is Michael Cervenka. I'm the Chief Commercial and Technology Officer at Vertical. I've been at Vertical 5 years now, so relatively one of the longer standing employees at the company. But as is quite typical for employees at the company, I've got a strong background in aerospace. So I did an aeronautical engineering degree. I spent over 2 decades at Rolls-Royce. Most of that was developing gas turbines for a whole range of initially military, mostly civil aero engines, all the way through the life cycle from certifying new aircraft engines and looking after legacy products. But then I spent 4 years working for the group CTO, looking after future technologies across the entire Rolls-Royce group. And so part of that was a big drive on sustainability and also what were the potential disruptive new aircraft platforms and wider platforms that might present opportunities or threats for Rolls-Royce as a power and propulsion system provider. So actually, I've been working on eVTOLs, and I don't think anyone knew what eVTOLs were at the time, for probably 9 years. And I guess the opportunity came to come and join Vertical, but it was really a realization that we were reaching that exciting technology tipping point where it was going to be possible to develop a commercially viable electric aircraft that actually would serve a real purpose for society. And so I'd kind of already bought into the fact that eVTOLs were going to happen. There was a big commercial opportunity, big market opportunity. We've obviously seen that happen since. But also it was a real disruption in aviation, where if you think about what's happened since the dawn of the jet age in the 1960s, most of aviation has progressed on a phenomenal safety record, but essentially incremental improvements on an increasingly mature technology base.
Mm-hmm.
And so aviation's become very good at doing that. But here we got something where there's a totally new type of technology that opens up a completely new way of designing an aircraft. And so the barriers to entry and how you do that are fundamentally different. So we can touch more, and I won't give too long an answer to your first question, but I sort of strongly felt actually it was going to be startups, at least at an aircraft level, that were going to lead the way. And so when I got approached through Stephen to come and join Vertical 5 years ago, actually it was a really easy way in to say, hey, there's this amazing potential, some super smart engineers, but in a very different culture and environment to really pioneer and disrupt. So that was kind of why I joined Vertical 5 years ago.
Yeah, a big leap actually, because obviously Rolls-Royce is very well known, established name in the industry, and as you said, this is a completely new segment of the industry that is kind of redefining the future of aviation. As I say often in the introduction to this podcast, Vertical Aerospace at the moment is, I think, when we are recording this podcast, has just completed phase 1 of flight testing, which I think it involves pilot flight, but tethered. So it's not completely free flight, because the aircraft is kept tied to the ground by some cables. Well, it's not static, but it doesn't move much. So let's go one step back, maybe. Tell us first, please, in a few words, define us the main characteristics of the eVTOL that Vertical is developing, the VX4. And then we can maybe go over the, let's say, this development plan and the next stages in the development. Once this flight testing is completed, there's going to be a few more steps towards certification and entry into service. But let's go first to the main features of the aircraft. What is your unique selling point? What's your differentiator in this market that is seeing so many different projects evolving in parallel?
So I think the first thing to say is eVTOLs are not just putting a battery into an existing helicopter. One of the things that's common with all of them is they use the fact that you distribute and control electricity around a platform far more easily and immediately than you can doing transmitting power through shafts, gearboxes, and so on. And so what that does is, if you think about what an eVTOL is trying to do, we're trying to take off and land vertically, but we're then trying to morph into something that flies like an aircraft. And the opportunity is, by distributing power, we can do that in a way that is fundamentally different. So what's the value that gives? The first, we can have an aircraft where we can build in redundancy. And so one of the, I think, unique things about Vertical and very few of its competitors, we're actually aiming for the highest safety standards being set globally. Those are being set by the European regulators, also adopted by the CAA. That is the same safety standard as is set for a commercial aircraft, so 1 in a billion failure rate. And so if you think about helicopters, well, helicopters today, amazing craft, they can take off and land vertically, but they're not allowed to fly over many cities because of safety. And yet we don't bat an eyelid about the latest, big commercial aircraft flying over. So that firstly opens up routes that you can't do in helicopters. Secondly, we can actually design the aircraft and its fundamental physics in a way that is significantly quieter. So if you hear our aircraft in the testing we've done, it is substantially quieter, even as a prototype, than even the quietest helicopter. So we have a Robinson helicopter that our pilots use for keeping currency. It's just a very different type of sound and much quieter.
And why is so? Because you are using rotors after all. And
we're using rotors, but there's a fundamental physics thing. So this is probably the most technical we'll get in this discussion. But helicopters generate lift through one main rotor. And if you think about it, that's fine when you're in the hover. As you start to fly forward, you have an aerofoil that is going into the wind. That's called the advancing blade. But then when it comes around the other side, it's the retreating blade. It's going away from the direction of flight.
Mm-hmm.
So you actually have to have that rotor blade going much faster, the tip speed of that rotor much faster than the aircraft speed. Otherwise, it would stall on the retreating side.
Okay.
And literally the helicopter would flip over. So that drives you to having a high tip speed on the helicopter rotor, and that's what generates the noise. And the other thing, because it's a very big rotor, has a relatively sort of lower frequency, you hear the what noise.
Mm-hmm.
So it's a loud noise, but it's also got this sort of quite penetrating what sound.
Okay.
With an eVTOL, we have propellers on both sides of the aircraft, and half of the propellers rotate one way, half of them rotate the other way. So we balance lift across the aircraft in hover, and as we start to fly forward, that means we have about half the tip speed compared to a helicopter rotor, which actually means it's 30 times quieter, because
30.
it's 30 times quieter.
Wow.
So and then we don't have the what noise. It's a sort of broadband noise that blends into the background. If you hear our aircraft, you can have a normal conversation quite close to the aircraft. Mm-hmm. And then, of course, when you're in cruise, we design the aircraft to be incredibly quiet. So think of this as something that is about the sound of a loud conversation in hover and about the sound of a domestic fridge when it's flying in cruise. So it's really disruptive in terms of noise. It also avoids all of the sort of maintenance and safety issues that you get with helicopters. And then, of course, it's zero emission. So fundamentally, it disrupts on safety, on noise, on operating cost, and zero emissions.
The redundancy, the safety, enhanced safety, I guess is provided by the redundancy that the additional engines bring to the craft, or are there any additional features that I'm missing here?
So the main one comes from redundancy. If you think about the helicopter, there's about 60 components that are critical parts in a helicopter, where if any one of those fails, you can't continue safe flight to your destination. In an eVTOL, if you design it right, so there's lots of challenges to get to this point, but it has the potential where you can design it so you can actually have combinations or multiple failures. The aircraft can continue flying. Okay. So we have redundancy, for example, in the motors, in the power distribution, in the batteries, in the flight controls, etc. So that's the first driver. The components themselves don't have the same sort of mechanical stresses that you'd see in a helicopter. But also we have a very sophisticated flight control system with Honeywell that actually makes it far easier to fly. So I've literally had journalists come in and on our simulator with 1 minute training able to take off and land and maneuver the aircraft. So if you think about the pilot's mental capacity being absorbed to just keep a helicopter in hover is quite significant. Whereas eVTOL, all of that's freed up, and the pilot therefore has all that capacity to think about, any arisings, communications, operational stuff. So I think operationally it's got potential to be safer as well.
But doesn't the tilting mechanism kind of counterbalance the simplicity that you get from other elements of the system?
So I haven't really. I've talked more about why eVTOLs. I should talk now a bit about why the VX4. And so one of the differentiators is that safety. There are different standards. Not everyone is going for the same safety standard. I think in your recent podcast, Mark Timblecki talked about one of the reasons Avolon is the second biggest leasing company. Leasing companies buy most of today's aircraft. Their job is to buy aircraft. Having that higher safety standard is a huge deal for them because it means our aircraft can be operated all over the world. And so if you're leasing company, you care about what's the residual asset value, what's the portability of the asset. So that safety standard is really important. We have an aircraft that we've designed around today's technology. So it's really difficult to pull all these different pieces of technology into a viable vehicle, but we're not relying on something that is in a lab. So, an advanced battery system that is not yet there in terms of the battery cells. But so there's an advantage there in terms of risk to certification. But also we've designed it in a way that's much more upgradable, and we'll talk more about that when we say more about the cert aircraft in due course. But actually, we fundamentally have a platform that is more upgradable. I think we benefit significantly by the fact that we are an OEM, so we're not trying to operate the aircraft. We've got a very simple business model. So when we talk about selling to customers, it's not like we're saying on the one hand, we're going to sell you an aircraft, but then we might also be competing with you in operating aircraft. It's very straightforward. We benefit from having an amazing set of partners, so the likes of Honeywell and GKN and Leonardo and ScienceQ and Hanwha, so real aerospace pedigree. But then to your specific around the aircraft, the aircraft we're flying now that you touched on is our fourth prototype. And I think one of the strengths we've had is in Stephen Fitzpatrick, who founded the company. He's given us that flexibility to learn and evolve and migrate to the optimum platform. And we've had huge amount of insights from our customers as to how they're going to use the aircraft. If you look at our configuration, we have a wing, and a wing is fundamental to you being able to fly fast and to carry, in our case, 1 pilot and 4 passengers. But we also have 8 propellers. And when you sort of figure out where you have to fit the aircraft within a 50-foot or 15-meter diameter landing spot, 8 propellers gives you the biggest propeller area. And so that's the most efficient configuration in terms of hover for a given weight of aircraft. And then why tilt? So tilt, you're right, it adds some complexity in terms of the mechanism, but it is massively helpful in terms of the controllability of the aircraft, the maneuverability of the aircraft, the ability of the aircraft to deal with things like gusts with failures. If you even think about something like yawing the aircraft, if you don't tilt the propellers, you have to speed half of the ones that rotate clockwise up and slow down all the anti-clockwise ones, or vice versa. That's very inefficient and doesn't give you much control over the aircraft. If you think about trying to land, slow down and descend an aircraft, if you can tilt the propellers back, you can control that descent profile much more easily. If you have a failure, you've got more means of controlling the aircraft. So yes, the software is more complex, and working with Honeywell is critical, but you actually end up with a much more capable vehicle as a result. And then the final advantage is at a really fundamental level, actuators are lighter than motors. So nothing else changes. If you have a lift and cruise, you're carrying additional motors. So this is where nothing moves. You've got one set of propellers lifting you up vertically, another pushing you forwards. So that's inherently going to have a compromise on performance compared to a tilt configuration. So those are just some of the features that I think give us an advantage. Wing for the speed and capacity, 8 propellers gives us a real efficiency. Tilt configuration gives us all of that safety, redundancy, maneuverability. And then the gradability of the aircraft, which we'll touch more about later, really means we can capitalize on things like improvements in battery performance as they get better over time. We have 8 propellers. Each propeller actually has 2 motors, so effectively we have 16 motors, but 8 propellers. And if you think about it, you need the propellers to be balanced in front and behind the wing, so they're centered around the center of gravity. If you have fewer propellers or more propellers, actually the total area of those ends up being lower because you're more constrained on how you fit them.
Let's go to the main characteristics, the performance of this aircraft. I don't know if that's the case already of the prototype you're testing, but what's going to be the range? You mentioned the capacity, so it's going to be 4 passengers and a pilot. What's going to be
Yeah.
the speed and range of this aircraft?
So the speed is up to 150 miles an hour. Typically, we'll cruise at 125 to 150 miles an hour, depending on the mission. The range is up to 100 miles, but we should talk a bit about some of the use cases. Many of the flights are actually quite a bit shorter. So the important thing there is the efficiency of the aircraft with the efficient wing and the propeller system means we can do really rapid turnarounds because we're not
Mhm.
using that much energy on short flights.
The 100 miles includes a reserve, or it's operational 100 miles?
Yeah, so I mean, we tend not to quote specifics because some of the operational
Okay.
requirements will be performance based.
Hmm.
Um, Most of the missions will be a lot shorter than that, and then depending where you're flying, the operational reserves will be different in different parts of the world. So the customers is not so much can I fly 100 miles, it's can I do a shorter mission and can I turn the aircraft around really quickly, and
Hmm.
what's my payload, and things like the luggage capacity we've got is really class leading.
So 4 passengers and a pilot. Does it include baggage? Are they gonna be able to carry more stuff apart from
Yes. Yeah,
themselves?
and we've got loads of baggage space because if you can
Okay.
imagine, some of the customers are going to need to carry quite a bit of baggage. So yes, there is. We haven't declared the actual mass limitation,
Hmm.
but it includes plenty of margin for 4 passengers, a pilot, and their luggage.
Okay. And it's fully electric, battery electric. How long? Well, I guess that would depend on how the battery technology evolves, but what's the expected charging time with the current technology?
So it depends on the type of mission, but for the shorter missions, it's around about 10 minutes, 10, 12 minutes to turn around the aircraft. That includes cooling the aircraft, cooling the batteries down.
Hmm.
Um, so if you think about how long it takes to get the passengers off and back on, actually you're not spending much more time to charge the aircraft.
Hmm. You mentioned you are now already on with a fourth prototype.
Yeah.
I think this summer you presented the latest iteration, which I think has significant improvements over the previous one. And you made your team made a big point of the fact that now a significant portion of the aircraft is made with parts, components, materials that are provided by tier one suppliers. Why is that so important? And why is this, let's say, a positive development on the path to market?
So different eVTOL companies have taken different strategic approaches. And if I sort of compare and contrast, Joby's probably the opposite end of the spectrum, where they've chosen to vertically integrate almost everything, both on the aircraft and in fact also in their go-to-market. So they aim to be the Tesla and Uber of the skies, but they literally are going to fly their aircraft. They're making every single component. We've gone down the approach of we're at the end of the day, we're a startup developing a very novel aircraft, aiming to certify it to the highest safety standards and to meet a huge global market opportunity where we're undoubtedly going to be supply constrained for quite a number of years. And we think that there's a better, in our view, approach to that, which is fundamentally Vertical has got real expertise in the overall aircraft. So how you design the aircraft at a platform level, the systems integration certification and so on. And we then have two key technology focus areas within the company. One is around the battery system. So we don't do the cell, but everything else in the battery system we do. All of the casings, the thermal management, the
Uh-huh.
battery electronics, software, and so on, we do in-house.
You assemble the packs, the battery
They
packs. Yeah.
assemble the packs, etc. And the
Uh,
reason
ma-
we've done that is you can't go out and buy today a capable battery system for primary propulsion in aviation that delivers the performance we need. And
Mhm.
we've actually hired quite a lot of ex-automotive people, but we've put them in an amazing environment where we've got a dedicated battery development center. It's one of the best in the world. And we've just been able to iterate so fast and find out how we can get weight out and how we can meet all of the safety requirements. So actually the prototype we're flying now, we've effectively put the battery through a mini certification program because we've done all of the thermal runaway, shock, vibration, etc. tests. We did,
Mm-hmm.
I mean, we've done the crash tests on this. We started doing those probably 5 years ago.
What energy density are we talking about now as we speak now?
We're north of 200 watt hours per kilogram at a pack level.
Uh-huh.
So we're targeting 2 to 220. But that's also meeting the higher safety standards, but that's doing it with battery cells that are commercially available, not battery cells that are in the lab. So that's one of the key things we're doing. The other is the propeller system, where the propellers are key to noise and performance of the vehicle. And again, they're very different from a conventional propeller aircraft or a helicopter rotor. It's really differentiated technology. Everywhere else in the aircraft, we've aimed to partner with the best suppliers and tier one. And I deliberately use the word partner because we're co-innovating and developing, and it's not like we kind of come up with a set of requirements, throw it over the wall, and they come back with a solution that we just plonk in the aircraft. We have to do it very collaboratively. But I think that brings a huge advantage. It means that we're very capitally efficient. We spend less than a quarter of the sort of run rate that our competitors are spending. We've got a team of about 360 people. Many of our competitors are now up well over 1,000 people, even nearly 2,000 people. It means we're really focused on what we're good at. We're not reinventing the wheel. And those tier one providers bring huge technology pipelines, deep certification experience and pedigree and proven track record, industrial capabilities that in many cases, because of COVID and some of the wider aviation challenges, are currently underutilized. So they don't, none of us are having to build lots of expensive factories on day one. And they also have global support. So if you think about the 4 steps of the 4 prototypes, the first 2 were non-winged, which were just about getting the company to learn how do you integrate battery systems, propellers, flight controls. The third prototype I would describe much more as a flying rig. It was winged, it was full scale, and that was very deliberate because that gives us the validation of our engineering tools and methods and simulations at a representative scale. So we're not kind of extrapolating a long way. But it was never intended to be something that was going to do lots of piloted flying.
I would like to mention there was unfortunately an incident where one of the prototypes, I think, crashed. I think there was no one on board.
Yeah, that one.
There was a third one, yeah?
Yeah.
What were the lessons you learned from that incident?
Huge lesson. So we were lucky in the timing. As I mentioned, it was not a prototype that was ever going to do lots of piloted flying. It wasn't cleared for that kind of level of safety standards. It was developed when Vertical was still a smaller company, didn't have the finances or reputation or partners that we have now. And it was aimed really to get us an early learning of how the vehicle performs, and particularly in the highest power, low speed domain, to optimize things like how big do you need to make the motors and the batteries, and how do you tune the flight control system so you've got good handling qualities. And we got all of the data and more that we expected from an engineering perspective. We flew in and out of ground effect at up to 40 knots, fully mapped out the performance of the vehicle, got really good handling qualities for the vehicle and lots of valuable lessons. And then the irony was, on the very last flight of the last test point, we lost a propeller. And the propeller was an early standard. Ironically, we'd redesigned it with a completely different method of manufacture, design, method of manufacture, supplier, validation. We were going to retrofit it, but it just hadn't come through in time. So the propeller, ironically, we'd already learned the lessons about, the next generation of propeller is just fundamentally different. We've put it through millions of cycles of fatigue testing and so on. Some of the behavior was exactly as expected. So the propeller that released in the route, the out of balance damaged the pylon, that was expected. What was unexpected was we basically caused some interference in some of the communication wires between the flight control systems and the other motors. And so having lost that propeller, effectively we depowered other propellers. And so the aircraft at that point didn't have enough power to maintain hover. The control system then keeps the aircraft flat because it's better to land flat than to roll over. But effectively, we ended up with a hard landing. Now, positives, the fuselage was intact, the battery systems were intact, the high voltage systems were all protected. We didn't have any kind of wider shorts or, short circuits. But we learned a lot around both the architecture of where we put cables to communicate between the control systems so you don't have this cascade effect, but also some of the software. And actually, we shared that both with lots of regulators, with our competitors, and I think that's a benefit to the wider industry. Jump forward to where we are now.
Yes, the fourth prototype, yeah.
And the fourth prototype is really different. So, I mean, it's white rather than black.
Yeah. Well, externally, it looks similar from the outside, but I guess there's plenty that it's different inside.
I mean, it's 90-something% completely new on the inside. And one of the big differences is it's been designed from the outset for piloted flight. And so it's got a huge amount more integrity in the hardware, in the manufacturing, in the architecture, in the safety work. And I think it's really important to differentiate what that means in terms of flying piloted in the UK. So, I mean, our chief test pilot, Justin Paynes, used to be Joby's chief test pilot. We know a lot of what the competitors do. If you want to fly a remotely operated vehicle in the US, there are lots of remote areas you can do that in, where the level of rigor that you have to go through with the FAA is pretty light touch. For us to fly piloted in the UK, we don't have any totally remote areas in the UK. And we have to go through what's called a permit to fly process with the UK Civil Aviation Authority that is quite like a mini certification program. So we submit hundreds and hundreds of documents to the CAA around the safety of the aircraft. We've had to do a huge amount of testing. I touched on a bit of the battery testing, some of the propeller testing, but also lots of other tests, functional testing, simulation, and so on. And then we stepwise basically expand the envelope, and every step of the way, we have to get those CAA approvals. So as you said, we've just completed tethered flying. Actually, it's a loop tether. So the aircraft is fully free and able to fly. And it shows how good the handling qualities are, because you don't want the tethers to ever get taut. So we're flying in a fairly constrained environment where we've simulated things like motor failures, tilt failures, demonstrated that the aircraft is very controllable within a very sort of tight maneuvering space, never pulls on the tethers. It's just done to make sure the aircraft is functionally working. And then over the coming weeks, we'll progress on to phase 2, which is where the tethers come off, and then we can start flying free.
You're testing at Cotswolds Airport, is that right? In the UK. We didn't mention at the beginning of the podcast, but you are, I think, the only UK eVTOL developer and one of the few in Europe that is so down the road in terms of development. Just mentioning here because I just remember that I think that has implications also from a regulatory point of view, as you mentioned, because you are under the umbrella of the CAA, the British Civilian Aviation Authority, but you are also pursuing, I think, the ASA and I guess FAA certifications as well.
So being UK, I think, gives us some real advantages. We've got a huge track record in the UK for aviation. We're still, I think, the second or third largest aviation exporter in the world. We have a huge amount of talent. We're based in Bristol, so we're actually surrounded by, believe it or not, 270 aerospace companies. So that's fantastic in terms of talent, in terms of access to suppliers, research, good universities, test centers. So, for example, we do wind tunnel tests at Airbus's wind tunnel facility just up the road from us in Bristol.
Mm-hmm.
We are, as you say, the only really credible UK eVTOL company. We get a lot of support from the UK Civil Aviation Authority, a really strong relationship with them. But as you indicated, I think very helpfully for us, the UK has adopted the same certification regulation standards, what's called SC-VTOL as EASA, the European regulator. And we have already a signed bilateral agreement where EASA and CAA are working together on our certification. In addition, because of that global order book, we have heavily engaged with the FAA in the US, with ANAC in Brazil, and with JCAB in Japan. So
Uh-huh.
those are the major sort of regulators that we're working with.
You've got all these different certification authorities that you are talking with, because obviously, as you mentioned, there are so many prospective customers. Well, not prospective, they are already kind of committed to introducing the VX4 whenever it becomes available. And we had Mark Tembleke of Avolon a few days ago here on this podcast, where he explained how Avolon placed 500, which is a very large number. I think it's the largest, let's say, I think it's the Avolon might be the largest eVTOL purchaser in the world, I think, in terms of
Yes.
volume of orders. And it has placed these 500 aircraft with a handful of airlines that include some very prominent names like Japan Airlines, AirAsia, Air Greenland, and some others. So a very broad spectrum of climatic conditions and markets and potential use cases. I mean, I'm thinking here about Greenland in the winter, which I guess it's proof that the system is designed to withstand really harsh conditions. And then also companies like AirAsia that will potentially operate it in tropical climates. So what can you tell us about this sort of resilience of the system to operate in all these very broad range of conditions?
So I think it's worth firstly just talking a bit about the customer base we've got and the use cases, and then I'll come on to a bit about the
Please.
opportunities. So we've got an order book of about 1,500 aircraft globally. That is roughly split 1/3 in North and South America, 1/3 in Europe, 1/3 in Asia.
1,500, because I was referring to 500, but I want to clarify that's just the Avolon order.
That's just
Then
Avolon.
there are other orders that are not related to Avolon that come from other customers independently.
Exactly. And if you look at those orders, yes, they include Avolon as the second biggest leasing company. As I mentioned earlier, lots of aircraft typically are bought by leasing companies. They can access better credit ratings and so on. That's a good way for airlines to finance aircraft. We've got, I think, you mentioned some of them, sort of major airlines, but also including American Airlines, Japan Airlines, Virgin Atlantic. We've got Bristow as one of the biggest helicopter operators in the world. We've got tourism companies like Iberojet, Gol, major sort of operator within Brazil, etc. Low-cost operators like AirAsia. So there's a real spectrum of customers. And a real spectrum of geographies. And I think that's very important in terms of showing that there's a diverse market opportunity. And also it means we're resilient. For example, if one region, one regulator or whatever ends up being a bit slower. So it's good to have that kind of portfolio customer and approach. What stands out, we've done I think, one of the strengths we have is a really close relationship with our customers. We run Pioneers events where we get them all in for a couple of days, multiple times a year. We talk to our customers every week. In fact, I was just talking to Marabeni, one of our customers, earlier this morning. And we've got a really sticky engagement with them, where they're really helping us to understand how they're going to use the aircraft, how we optimize the aircraft. And as an example, we've done a lot of work with customers using mobile phone data, understanding where do people travel today. And fundamentally, what we're trying to do is offer a time saving. So where can we offer a saving of time? How does that compare against other forms of transport? What's the affordability to pay for that time saving and so on? What stands out is that there are three major launch mission use cases, and we see this replicated in lots of different parts of the world. The biggest one is connecting airports to the surrounding catchment area. So it's not necessarily a major hub airport into the nearest city, because depending where you are in the world, sometimes there's quite good tubes or other kind of ground transportation to do that. But often the surrounding catchment area is quite poorly served. So if we think about somewhere like the UK, going from Heathrow Airport to Cambridge or to Brighton today is a real pain, whereas we can fly in a significantly shorter amount of time. Whereas going from Heathrow to the centre of London, you've got Paddington, you've got the Heathrow Express and etc.
And I guess that's one of the use cases that might be particularly interesting to many of these airlines that you mentioned. Thinking about the American Airlines, Virgin Atlantics, and all these guys. Also because they can offer a premium service to the highest tiers of passengers as well to move to and from the airport.
So that's one of the use cases. The second one that crops up inevitably is a tourism one. So whether that's flying to luxury hotels, whether that's doing sightseeing and so on. And then the third is there are plenty of examples where there are just gaps in the ground transportation infrastructure. And it might be because there's a mountain or hill range in the way, or there's a body of water. So, in Osaka, you've got the Osaka Bay. In the UK, Manchester to Leeds with the Pennines in the way. There's lots of these kind of examples. In terms of kind of how we see the market rolling out.
Sorry, if I may stop you 1 second here. What about other use cases that are not strictly speaking for passenger transport? I'm thinking here about defense, logistics, emergency services. Is this a market that you are also actively targeting?
So we're involved in some of those markets. So firstly, in medical emergency services, there are definitely use cases there. If you think about it, most of the EMS providers are charities. They run on a really tight budget. The cost of helicopters is a real challenge for them. More, this will be transporting from one hospital to another. At the end of the day, battery-powered eVTOLs can't spend a long time in hover, so there are things that helicopters can do that eVTOLs can't, but there are some really valuable use cases there. Cargo, there are some use cases. We focus more on the passenger side because fundamentally we're saving time, and we and actually lots of the sort of independent analysts view the passenger market as a bigger opportunity. It's harder in some ways because when you want to carry passengers and you want to fly over built up areas, things like noise and safety become more demanding. But that also creates opportunities to differentiate and create barriers for entry. And it's just a bigger, people generally are more time sensitive. There's obviously bits of cargo that are time sensitive, but people are generally more time sensitive. The willingness to pay to save time is more prevalent for people. On the military side, there's an interesting space, and actually I think recently announced we're within a UK MOD framework for future heavy lift activities. Firstly, it's worth saying we're not going to do weaponized platforms. So the military opportunities we see are much more around medevac and logistics and those sorts of types of missions. The VX4 actually has some real advantages in terms of potential hybrid solutions and abilities to sort of offer solutions within a military market. We see that very much as an adjacent opportunity. It helps in terms of diversifying our routes to market, potential to get some military funding. Certainly some of our US competitors have been quite successful in doing that. It's not going to be as big a market as the commercial market. So I would say it's there, it's worth pursuing. The prime focus of Vertical continues to be a pure battery, passenger carrying commercial operation. 50% of the missions they want to fly are less than 35 miles.
Okay.
Most of the missions are less than 60 miles, because there's lots of places where things are really congested. You don't have to fly very far to save
Yeah.
1, 2, 3 hours of time. So
Yeah.
yes, of course, there are opportunities to fly further where you'll need a hybrid solution, but actually most of the use cases are quite short.
Mm-hmm. And where are you now in terms of the certification process? You completed the, you're going to move now onto the, as you mentioned, untethered flights, test flights. What comes next, and what's the time frame that we should be looking at for, let's say, completing the certification process, at least here in Europe?
So I think firstly, to just touch on the timeframes for the prototype. So this
Sure.
isn't certification. This is really proving out the technology and validating all the models.
One
On
question, this fourth prototype you're testing now, is it the, let's say, the final before getting into certification or stage, or there are going to be more prototypes along the way?
It's the final before getting into cert. We're actually building a sister aircraft 3, as we
Okay.
call it. One's called aircraft 2.
Okay.
Those are the last prototype aircraft before we go to the cert aircraft, but they're not conforming, they're not certification aircraft.
Mm-hmm. Okay.
They're really important in terms of piloted full-scale flying to really prove out the technology, prove out the capability, validate our models, enable us to go through a cert program with the lowest possible risk and maximize the performance we're going to get from the aircraft. So that's really the purpose the prototypes serve. We are within the next few weeks, we're just, finalizing the paperwork with the UK Civil Aviation Authority for untethered, what we call thrust-borne flying. So this is where the lift of the aircraft is still predominantly delivered through the propellers. We then go to wing-borne, so we can actually take off and fly like a normal aircraft.
Mm-hmm.
And then finally, we do transition, where we'll actually fly to altitude conventionally, and then we will slow down to a stop, and then speed up again, and then we've completed the whole flight envelope. So we'll do that over the coming months.
One question, if you don't tilt the rotors, can you take off and land with the, let's say, in horizontal flight mode?
Yeah.
Okay.
So that's what we'll do after the next thrust-borne, where literally we take the front propellers to a normal forward thrust position. We just fly like a normal aircraft.
Okay.
So yes, the aircraft can fly like a normal aircraft as well as it can take off and land vertically. So we do all of that over the coming months, and then off the back of that, we will do some public demonstrations. The intent is to fly to Bicester, where Skyports, one of our partners, is building a dedicated vertiport, to fly into Heathrow. Both of these are part of a UK government-funded Future Flight Challenge program, and then the Osaka Expo. So for us, we've done a lot of the sort of heavy lifting. We've been perhaps quieter in the market, but really off the back of that, we've got this opportunity to really demonstrate and in many ways kind of leapfrog some of the competitors with that full-scale piloted transition flying and demonstrations. In parallel, then, we take all of that learning into the certification aircraft. So as I mentioned, we're working with 5 regulators, and we are proceeding through the kind of detailed means of compliance certification basis work, initially with the UK CAA and EASA, but keeping FAA, ANAC and JCAB in the US, Brazil and Japan informed.
And do we have an approximate date for what could be a potential certification and entry into service timeframe?
So the target date we currently have is end of 2026. I mean, that's challenging, and you can imagine we keep those things under review. That would enable a 2027 entry in service, but that's work that we're going through. I think it is worth saying, for me, this isn't a winner takes all or you have to be first. I think one of the differences that we're taking is we're not just trying to develop a minimum viable product that's kind of got the minimum bare bones to get certified and get into operation. We're developing a product that is the highest safety standards, but actually with significant upgradability inherently from the start. And so we might be a bit slower than some of the others certify, but I think you've seen from the order book, and not just the size of the order book, but the pedigree and the sort of reputation of the customers that we've got. we're really aiming to have the best possible product out there and to use that as an ability to then scale up. So also being realistic, this isn't something where we go into market and suddenly we're producing hundreds and thousands of aircraft on day one. This starts relatively slowly with tens to then low hundreds, and we grow from there. So to your earlier point, yes, of course, just like mobile phones, when they first came out, they were, a premium product. This will, of course, initially go into operation in the most valuable routes, but the technology is already there to enable this to not just be the very few front rows of the aircraft where this aircraft is sort of appealing to. Over time, as we build up production and we have more aircraft in service, that inevitably, it'll become more pervasive in terms of who's able to benefit from this.
And any indication of who or where would be first to use the VX4?
So, I mean, I think there's an obvious, so I'm not going to go into specifics on that because that's obviously commercial discussions we'll have with our customers. I think it's worth saying they're all desperate to get the aircraft early. There is an obvious sequencing. So we are doing a concurrent certification with the UK Civil Aviation Authority and EASA. And then we will follow a classic foreign validation approach. So our objective is we hit the very highest safety standards being set globally. So that's an umbrella. And it's a very well-trodden bilateral sort of approach that's already well established under the ICAO, so the UN sort of aviation body. But inevitably that says UK Europe is the first to certify, and so logically is a good place for us to start. But then, I've already talked about the 5 regulators we're initially working with. So you can deduce, therefore, that America, Brazil, and Japan are sort of running quite closely behind.
And provided that everything goes according to plan, what is the industrial roadmap? You mentioned you have very close partners. We didn't mention them, but I think it's public that some of them are companies like GKN Aerospace, Honeywell, you mentioned it, and some others that are very closely involved in the project. I guess you are going to assemble all these sub-assemblies and parts and components that are produced by these Tier 1 suppliers. Are you going to assemble them in the UK? Are you going to build a new factory? What capacity? What production capacity are you expecting to have, at least in these very initial stages?
So there's 2 bits Vertical will do. We already assemble the battery systems, and we will just expand out from the capabilities we already have in place. So we can, in fact, already support some of the low-rate initial production and certification, even from our existing battery development center. And we're building out the capabilities to then take that into a production environment. And then we will assemble the final aircraft. For us, that's really a pretty straightforward activity in terms of the facility. So the objective is we get all of the major subsystems as much as possible already fitted out by our suppliers. So essentially what we're doing is bolting and plugging together major parts of the aircraft. So of course you need the right skilled technicians, mechanics, the right, production approvals to do that. But you don't need some very fancy big factory with lots of automation. The intent is the initial aircraft will be assembled in the UK, and they're designed to go in shipping containers so that we can then, we fly them in the UK, prove that they've met all the initial requirements, partially disassemble, which is actually a very quick process, send them wherever we need to in the world and reassemble them. Over time, I would imagine as the market grows, we will end up building out some regional assembly lines, but we don't need to do that on day one.
And what's the production capacity? Yeah.
In terms of volumes, it's tens in the first year, and then it's building up to hundreds. It's years before we get to thousands. We're doing quite a big exercise at the moment, working through an updated financial and capital plan. And over the coming months, I think we'll get a lot more prescriptive about, how we ramp that up. I think the great thing is, we certainly, everything we see, we're going to be supply constrained. So particularly things like the major composite structures, nobody's going to build a massive factory to build lots and lots of composite structures for a new aircraft right now. So we can leverage the existing spare capacity in the supply chain. Once we're in service, we've proven out the aircraft, the ecosystem's ready. I think that's when we'll get into us and partners building out new facilities. So we manage the investment. We can be, because of the sort of capital-light business model, we're actually very profitable very early on. So we don't need to be producing hundreds and hundreds of aircraft a year to break even and to make money.
But I guess
that gives us the foothold to then ramp up.
I guess you might still need to raise some additional capital, I guess, for this. Yeah.
And in fact, we even talked I think we just released our half-year results.
Yep.
We've got the capital runway that runs into next year. We will need to raise some more money, certainly to get through to certification. Most of that is on the aircraft development. Back to we don't need to spend huge money on big fancy factories and facilities. There will be some further investment, actually more in the supply chain, I think, when we get to much higher volumes. But then that's an easy capital sort of investment to make at that point.
Excellent. Well, that's a pretty nice summary of this very exciting project that really hoping to see the VX4 flying soon, because it looks amazing from outside. Also, very good looking aircraft, I must say. For people that wish to learn more about this project, about Vertical Aerospace and the VX4, what would you say are the top resources that they should tap?
So we obviously have our own website, verticalaerospace.com. We've got lots and lots of information through LinkedIn and elsewhere. So all the usual stuff. Look out for the usual feeds. I think there's some exciting videos, more and more coming. Certainly over the next few months, there will be more and more activities. And so, it's an exciting space. There's also conferences we go to. I was at the conference last week. I'm in Montreal. I'm at a conference in Istanbul next week. A number of the team participate more generally in that kind of wider engagement and ecosystem. So, it's the other thing I'd say. It's a cool aircraft to look at. It's a really quiet aircraft to listen to. So hopefully you come and not just see it, but hear it in some of the demos that we're going to do.
I have a question though. It's a bit of a trivial question, but I noticed that you changed the color of the prototype. It was kind of in darker shades at the very beginning, and the latest one it's completely painted white. Is there a technical reason for that, or has to do more like brand image?
Black looks cool, but in reality, composites much prefer white. So you talk about actually climatic resilience. So we don't get a lot of sun in the UK, but we do get some. Black absorbs heat, and so white aircraft
reflects the heat.
Reflects the heat, so you stay well away from any kind of temperature limitations on the composite materials. So that's most aircraft today are white.
Okay, so the whole the aerostructure is mostly it's composite. It's pretty much composite, all of it, or most of it.
We've got some metallic structures. Actually, the optimum solution involves some metallics, but most of the structure is composite. All of the skins are composite. A lot of the structural members are composite. So it's probably structurally 90% plus is composite.
Excellent. Well, thank you so much, Michael, for your time today. I'm going to be posting links and notes to all the different points and items that we have been discussing here today, and wishing you all the best with the next stages of the flight testing path.
Thank you very much.
If you like this podcast, you can support us by giving it a great rating on Apple, Spotify, or whichever platform you get it from. And remember, you can, of course, subscribe to it. And you can also get regular updates through the Allplane website. That's ALLPLANE.tv. We have a newsletter where we cover the aviation industry every week with a special focus on innovation and sustainability. So give it a go. Thank you and goodbye.